All right, everybody in microeconomics land. Today we're going to do a quick video to review and wrap up everything we didn't have time to talk about with respect to the production possibilities frontier in lecture. So we're going to go through a model that is going to be really useful for Chapter 2 and Chapter 3 that I'm going to ask you guys to replicate before the next homework. And so remember, the production possibilities frontier is the second model we learn about. It assumes that we have two outputs and one input, and that there's fixed technology. And so the example that we're going to work with looks at labor hours producing either computers or wheat. And this example is in the book, it's in the PowerPoint slides, and I'm going to ask you to replicate it, and it's going to show up a lot. So you want to get a little bit comfortable with it because we are going to use it to explain a lot of concepts. So here we have, let's just label it our production possibilities frontier. So in this example, we're going to look at our one input being labor, one of our factors of production, and we're going to use that labor to either produce computers or wheat. And we're going to assume that we have, as our total input, we have 50,000 hours of labor. And we can use that to produce either computers or wheat. Now, each computer is going to take 100 hours to produce a single computer. So the cost of each computer is 100 hours, and the cost of a ton of wheat is only going to cost 10 hours. And so we can do the same thing we did together in class where we looked at a $50 gift card and breaking it down into $5 pens or $10 notebooks with this example of computers and wheat. So if you look at the slides, you'll see this broken down in exactly the same way. So we can say, okay, with 50,000 hours of labor, we can produce either all computers, all wheat, or any combination of the two, and that will give us the production points, the possible production points given our information. And so we can break those down. Let's go ahead and build a little chart over here where we've got the number of computers and the amount of wheat. I did not mean to do it that way because that's not clear. So let's say that should be a little bit clearer. Okay. And so if we spend all 50,000 hours of labor making computers, then by dividing 50,000 hours of labor by 100 hours per computer, we see that we can produce 500 computers. However, then we won't be able to produce any wheat because we won't have any labor hours left for that wheat. So then we can go and think of other options, like if we use 40,000 hours of labor for computers and 10,000 hours of labor for wheat, or 30,000 hours of labor for computers and 20,000 for wheat, or 20,000 hours of labor for computers and 30,000 for wheat, and so on until we get to the point where we're producing much more wheat and fewer computers, or finally all wheat and no computers. And at every stage, you can calculate how many of each good you produce by looking at the cost in labor hours and the total hours available, or the total hours available for production. So 40,000 hours when it costs 100 hours to produce each computer means we'll get 400 computers. 10,000 hours for wheat production when each ton of wheat costs 10 hours means we'll have 1,000 tons of wheat. In 30,000 hours, we can produce 300 computers, and in 20,000 hours, we can produce 2,000 tons of wheat. In 20,000 hours, we can produce 200 computers, and in 30,000 hours, 3,000 tons of wheat, and so on. And just like before, we see that the relationship between wheat and computer production, the opportunity cost stays the same. You can see that because you can see that pattern emerging, right? Every time we give up 100 computers, we get another 1,000 tons of wheat. And that's one of those important concepts that we get from the production possibilities frontier. That's one of those really great things. So now I want to go ahead and graph my production possibilities frontier. And so I want to go ahead and, like I said, start with an XY axis. And we'll do a lot of economic graphs this way. At the end of this chapter, there's a review of graphing and simple math, and that's going to be useful if you're not very comfortable with this stuff. If you are, and this is totally in your wheelhouse, then you're already set. For this point, it doesn't matter whether it's wheat on the x-axis or the y-axis, or computers on the x-axis or the y-axis. When we do look at trade in chapter 3, it is going to matter, just that you're consistent. So let's go ahead and build this production possibilities frontier. So I'm going to go ahead and copy the textbook and the slides and put computers down here. And wheat up here. And then it's not going to be perfectly to scale. We're not going to worry about that too much. It's not going to affect the things we learn from this model. So I'm going to go ahead and look at my possible quantities of wheat. We've got 5,000, 4,000, 3,000, 2,000, and 1,000. And then for computers, I've got 100, 200, and so on. And again, you can go through and graph each point, but really the most important thing, especially if you're not super comfortable with graphing, is going to be to find the two endpoints, the two extremes. What does it look like if I only produce computers, and what does it look like if I only produce wheat? That's going to give us our two endpoints. And because this is a fixed technology, this is a same opportunity cost all along the way. It's going to be just a straight line down between those 2 points. And so our production possibilities frontier is going to be just this straight line. And all along this PPF, this production possibilities frontier, are all of our possible combinations of production. And the book also makes use of the 50-50 point. So what happens if we use half of our time to make computers and half of our time to make wheat? Well, then that would just give us 2,500 tons of wheat and 250 computers right there. And there are a couple of big concepts that I want you guys to pull from where we are now. The first thing is that the production possibilities frontier, this line, is the frontier, is the maximum, is the limit, is the total potential for our production possibilities. Given how much labor we have and how much labor it costs to make these two things, these are all the possible combinations of computers and wheat that we could produce. We could produce 1 ton of wheat and 500 computers and no wheat, or we could produce 1 ton of wheat and slightly fewer computers. And remember when we talked about economists saying that people think on the margin? This is where some of that marginal analysis comes into play. A regular person would say, hey, there's not a point right here on the PPF. But an economist would say, sure there is. You could have 1 ton of wheat and 499 computers plus however much computer you could make with the remaining time. Does that kind of make sense? It's kind of a weird idea. But what we're saying is, imagine that every single point along this curve is possible and efficient. So they go ahead on the book and they give us, they label these point A, point B, let's say that's point C, point D, and point E. They are all possible, they're all efficient. And where you want to be on the production possibilities frontier in terms of what your combination of goods and services is going to be dependent on your preferences. So that's pretty cool. The next thing that's important is to think about what happens underneath and above the production possibilities frontier. And this is the part I'm going to ask you to do. I'm going to ask you to put this graph together, and then I'm going to ask you to answer these two questions. Pick a point that represents 100 computers and 3,000 tons of wheat and label it F. So let's go ahead and do that. I'm going to pick a different color pen so it stands out. So I'm going to look for 100 computers and 3,000 tons of wheat. Well, that's right here. I'm going to label that point F. And then pick a point that represents 300 computers and 3,500 tons of wheat. So that's going to be up here and out here. And we're going to call that point G. And this gets at the next big important thing about production possibilities frontiers. What's wrong with point F? Well, if you're a utility maximizing individual or a profit maximizing firm, you don't want to be at point F. You could be made better off. You could go to point D, you could go to this point here. Either way, you could have more of everything. As a country, we could produce more computers and wheat. Even if we don't want them, we could sell them to someone else. So we would never want to be below the production possibilities frontier. And that's another big idea. Any point below the production possibilities frontier is an inefficient point. We could have more by doing more. We have the labor, we want to use it. And so that's that example of, with the bookstore gift card, the idea of going in there and leaving with money in your pocket. Why would you do that? Especially if you assume like you can't save or something like that. What about point G? What's wrong with point G? It's producing a lot, but do we have the labor hours to produce that many computers and wheat? We don't. There aren't enough hours in the day. There aren't enough people. We don't have the technology. It's just not possible. So every point beyond the production possibilities frontier is impossible. So if this is our PPF, I'm going to take my beautiful graph and make it really ugly now. So if that's our production possibilities frontier, everything out here, oh, that didn't even work. Everything out here is impossible. That's not legible, I know. Everything that's underneath the production possibilities frontier, that's all inefficient. The only both efficient and possible points are along the PPF. Does that make sense? I hope so. If not, hit me up in the YouTube comments or in the discussion on Canvas and let me know. Take a crack at this. I'm going to post it as a participation activity assignment on Canvas, and you want to go ahead and get that turned in. And then I'm just going to wrap up with a couple more quick things about production possibilities frontiers. The other thing we want to talk about is the other types of production possibilities frontiers and the other applications. So remember, we started out with, and we've looked at so far, a production possibilities frontier that looks like this, right? A straight line that shows all the possible combinations of two goods or two resources. So we can think about this as being the PPF for hours in a day. And you can spend all that time either on Zoom or in person, right? And there's some combination there. We talked about the trade-off, right? The idea that if you move from one point to another, you're experiencing that opportunity cost by moving from, say, point A to point B. We are giving up some in-person time and increasing our Zoom time. Why would anybody do that? Because you have cool econ Zooms to go to, right? Okay, so now we want to look at another kind of a PPF, the kind that has a curved line. So let's get another axis. And now let's look at the production of bread and bicycles. And let's say we've got labor to produce either bread or bicycles. And let's make this really simple. Some amount of labor is used to produce either bread or bicycles. Does it make sense that the labor that it can be used to make bread is going to be the same as the labor that can be used to make bicycles? I'm not very good at making bicycles. I think I could make bread. So we might see in this case a curved production possibilities frontier for a really good reason. The labor used to make bread is different from the labor used to make bicycles. And so if we think about starting out at a point up here where all we're making are, let's say here, up here, all we're doing is making bread and no bicycles, right? So this is our all bread point, say point A. As we move away from making bread to making more bicycles, we're going to see the opportunity cost change as the slope of this curve changes. So if we go from point A to point B, let's say that's point F. You guys see that okay? That looks kind of clear. If we move from point A to point B, we are going to see bread go down by some amount and bicycles go up by a lot, right? And that's because the first people we take from bread making to bicycle making are going to be the people who are good at bicycle making. We're going to be sitting there in a bakery and say, hey, can some people go make bicycles? And the people who are good at it are going to say, yes, please, me, I want to make bicycles. And that means that we'll give up a little bit of bread, but get really good bicycle makers into the game. And they're going to do a very, very good job of producing those bicycles. When we move from B to C, we are going to see another decrease in bread because fewer people are making bread. But now we're not going to get as much bang for our buck for those bread makers turning into bicycle makers. My line's a little bit wobbly here. That's better. So we're going to still get a gain, but the opportunity cost has changed. The amount of bicycles we get for giving up the same amount of bread is different, right? We're getting fewer bicycles for each amount of bread we give up. Now we can go from C to D, and you can see the same thing happen. So we're going to assume kind of similar amounts of bread being given up at every turn, and now we're getting even fewer bicycles. Does that kind of make sense? So that's what the idea of a bowed out or a curved production possibilities frontier is trying to tell us. It's telling us that the technology associated with making bread and making bicycles is different. And so because as we are moving more and more resources towards making bicycles, those resources are going to be less and less good at making bicycles, and we're going to see a decrease in efficiency. So the next point we'd get would be, let's get another color in here. Let's try this one. Going from D to E, we're going to give up about the same amount of bread, and now we're going to get way fewer bicycles. Now we're putting resources that should be used for making bread into making bicycles, and we're getting a lot less. There, that's probably actually visible. Bang for our buck. Cool. So that's what the curved production possibilities frontier shows us. It shows us a change in opportunity cost. So we could see the same thing going the opposite direction if we wanted to, let's see, red, orange, green, blue. Let's use brown. If we go the opposite direction, if we're going from, say, F to E, when we go from F to E, we're going to see us give up a little bit of bicycles and get more bread. Cool? Cool. One more thing is that with either of these curves, we can see the curves move. if we have a change in the underlying technology. So if we go from, say, having, we started out here with our set amount of labor. Let's say we started out with 100 hours of labor. If we see a population increase and now we have 120 hours of labor, that means we can make more of everything and the production possibilities frontier shifts out. We could see the same thing happen if we had more hours in a day, or if we got the technology to do more Zoom meetings or more in-person meetings or something like that. So anytime we see an increase in the input or an increase in the technology, we can move that production possibilities frontier out. So there's an example that we can think of. So let's say we have a factory. It's a clothing factory, and it produces shoes and shirts. And we can either produce shoes or shirts using labor hours. So we're going to say we have 100 labor hours, and shirts take 2 hours and shoes take 5 hours. So that means that if all we did was produce shoes and we had 100 hours to produce shoes, 100 divided by 5 means we could have 20 pairs of shoes and 0 shirts. Or if we wanted to produce only shirts and we had 100 hours to produce shirts, we could produce 50 shirts. Or we could do half and half. I could spend 50 hours producing shirts and get 25 shirts, and then 50 hours producing shoes and get 10 shoes. So far, so good. So we've got, let's do this. Now, we've got our production possibilities frontier. Let's say as a company, we decide we want to produce here at point A, where we're getting 10 pairs of shoes and 25 shirts. We can see that the labor that we have, our workers, our 100 hours of labor, is equally productive, or they're equally good at producing either shirts or shoes, right? As we produce more shirts and fewer shoes, the relationship stays the same. We have a straight line relationship, and we can see the opportunity cost. We can see that if we give up 1 pair of shoes, we're going to get more shirts. So if we go from 20 to, let's say, 19 pairs of shoes, how many shirts are we going to have? We'll look at it here. If we give up 1 pair of shoes, if we go from 20 shoes in 100 hours to 19 pairs of shoes, that's going to take us 5 hours less. We're going to only spend 95 hours. That means we'll have 5 hours to make shirts. How many shirts can we make in 5 hours? Well, it takes 2 hours to make each shirt. So we can make 2.5 shirts in that time. Does that make sense, kind of? Kind of, right? Mathematically, it makes sense. If we have 5 hours, we can go through and we can make 1 shirt in 2 hours, another shirt in the next 2 hours, and then we'll have, 1 hour left to make 1/2 a shirt. And this is that economic concept of marginal analysis, making a decision on the margin. A normal person would say, you can't make half a shirt, but an economist says, why not? It's a point on my production possibilities frontier. Does that kind of make sense? So that gives us some information, that gives us our opportunity cost. So every time we decrease shoes by 1, we increase shirts by 2.5. We can check it over here. If we have 10 shoes and we want to go down to 9 pairs of shoes, how many shirts will we have? So if we have 10 shoes, that's going to be 5 hours per each pair of shoe. That's going to give us 50 hours. and 25 shirts. You see that, kind of? Is going to cost another 2 hours per shirt, 50 hours. When we move to 9 pairs of shoes, let me get a better color for you all. Now we're only going to need 9 times 5 hours to make those shoes. So that's going to be 45 hours, which means now we'll have 55 hours to make shirts, which means that in 55 hours, we could make 27 and a half shirts. Which is 2.5 more. Cool? Cool. If we, as a factory, decide to hire more workers, that's going to shift the production possibilities frontier out to a higher level. Maybe now we have 150 hours of labor. We could also say maybe demand has decreased, and so we're going to decrease production. So maybe we decide we don't want to hire more workers, we want to have fewer workers. We could shift the production possibilities frontier in and say, actually, we're only using 50 hours of labor. And so on. So that gives us a bunch of our big ideas from the production possibilities frontier. So take a look, try the in-class activity, and then on Wednesday, we'll talk about what questions you have and how else we can use this model to help us understand some of these really cool concepts. Okay? All right. So let me know what you think. Hit up the discussion boards. Have a wonderful weekend. And just as a side note, I apologize. I know this was a little bit of a choppy video. I'm getting used to the new board. It's not quite the ideal, but we'll get better with it with time. I hope you guys have a wonderful, wonderful weekend. All right. Be well.